Search theory is a branch of applied mathematics. It is not widely known outside the communities that use it. Search and rescue coordinators, naval officers, maritime search planners. But it is a mature and rigorous discipline with a history extending back to World War II, when the problem of finding submarines and downed aircraft in vast ocean environments demanded systematic solutions. The mathematics of optimal search developed from that necessity, and the tools that emerged have been refined over 8 decades into something that works. The core of the discipline is probability. Given what you know about a subject's starting position, intended route, behavior, physical capabilities, and the terrain through which they might have traveled, you can construct a probability distribution, a map of where the subject is most likely to be. This map tells you where to put your resources. It tells you, in mathematical terms, where to look first. The models are good. They are not perfect. No probability model is. But across thousands of documented SAR cases, the recovery statistics validate them. Subjects are found, on average, in the areas the models weight most heavily. The distributions are not random. They reflect real patterns in how people move through terrain when they are lost or injured. And then there are the exceptions, the cases where the subject is found in terrain that the models weight at near zero probability, not low probability, near zero. Terrain that the mathematical analysis says is not where a person in that situation, with those physical capabilities, starting from that position, should be found. These cases exist. They are documented. They are not common. The exceptional cases are a small fraction of the total, but they are consistent in their characteristics, and a search theory analyst who has spent 15 years studying them has found something in that consistency that he cannot explain, something that the mathematics did not predict, and that appears when you look at enough of the exceptional cases together to have a shape. His name is not given here at his specific request. He works as a consultant to SAR agencies, developing and refining probability models for specific terrain types. He has published in specialized literature within his field. He is not a paranormal researcher. He is careful to say, someone who has arrived at unusual conclusions because he was looking for them. He arrived at unusual conclusions because the data produced them. He became aware of the exceptional cases, not through any specific interest in disappearances, but through his professional work with recovery statistics. His job, in part, is to validate the models, to examine outcomes against predictions and identify where the predictions are systematically failing. The exceptional cases came to his attention because they represented the tail of the distribution that most significantly undermined model confidence. When he began examining them specifically, he found what he had not expected. They were not randomly distributed. He said, "The first thing you do when you find a statistical anomaly is check for selection bias. Maybe I'm seeing more exceptional cases in a specific region because that region has better documentation, not because the phenomenon is genuinely more common there." So I controlled for documentation quality, for search intensity, for the number of personnel deployed, for weather conditions, for terrain type. He said, "The exceptional cases didn't go away when I controlled for those variables. They remained concentrated in specific geographic areas." He said, "And that concentration matched something I hadn't expected." He said, It matched the geography of what SAR coordinators in those areas describe as their most difficult terrain. Not in the physical difficulty sense, in the specific sense of terrain, where outcomes regularly deviate from what experience and models predict. He had arrived, through statistics, at the same geography that the handler had arrived at, through dog refusal data, and that the weather coordinator had arrived at through atmospheric anomaly notes. The same places, by 3 independent routes. The specific mathematical signature of the exceptional cases is worth describing precisely. In a standard SAR case, the probability density function for subject location peaks in specific terrain types and decays at a rate that reflects the physical constraints on human movement. A person who has been missing for 24 hours, starting from a specific trailhead, cannot physically have traveled more than a certain distance in certain terrain types. The decay of the probability distribution reflects this physical constraint. In the exceptional cases, the recovery location falls outside the region where the probability density function has decayed to near zero. Not slightly outside, well outside, in terrain that would have required, given the elapsed time and the subject's documented physical capabilities, either a rate of travel that exceeds what human physiology supports, or travel through terrain that was already searched, or both. He described this to the researcher with the precision of someone accustomed to making technical observations accessible without losing their accuracy. He said, "The simplest way to put it is that the person is found where they physically could not have gotten from where they were last seen in the time available. Not should not, could not." He said, "In a medical or forensic context, when you have an outcome that couldn't have happened the way it appears to have happened, you start looking for what you're missing, what mechanism you haven't accounted for." He said, "In these cases, I've been looking for that mechanism for 15 years. He said, "I haven't found it." The specific terrain configurations that appear in the exceptional case geography have been the subject of his most careful analysis. He approached this analysis the way a good analyst approaches any complex variable, by disaggregating the data into its component parts and looking for what the components have in common. The drainages, the boulder fields, the geological transition zones, the specific elevation bands where the upper forest meets the exposed subalpine, the water convergence points, places where 2 or more drainage systems come close to each other, where the hydrology underground is complex, where the surface expression of what's happening below is visible in the specific vegetation patterns that colonize these convergence zones. These terrain features appeared in the exceptional case geography at rates significantly higher than their representation in the broader search terrain. He noted this. He developed a weighting system that attempted to incorporate these terrain features into the probability models, not as locations of elevated disappearance risk, but as locations where the normal relationship between starting position and recovery location appeared to break down. The models improved modestly. The exceptional cases reduced in frequency when the terrain-weighted model was applied, which meant the terrain features were capturing something real. But they did not disappear. A subset of the exceptional cases remained exceptional even with the terrain weighting. Recovery locations that fell outside the expanded probability distribution. He said, "The terrain weighting helped. It told me the terrain features are relevant, but they're not the whole explanation. He said, "There's something the terrain features are associated with that I haven't been able to measure directly." He said, "Something that affects not just where people end up, but how they get there." He said, "And how they get there is the part I can't figure out." There is a recovery case that he returned to multiple times in the conversation with the researcher. Not because it was the most extreme example, he had others that deviated more significantly from the probability models, but because it illustrated the specific quality of the exceptional cases in a way that the statistical description alone didn't convey. A woman in her 60s went missing from a wilderness area in the Cascades during a day hike. She was an experienced hiker. She knew the trail. The initial search, beginning the day of her disappearance, deployed substantial resources and covered the trail and surrounding terrain according to standard probability weighting. On day 3, as the search entered what coordinators call the expanded phase, when the initial probability distribution has been searched without result and the grid is extended outward, a team working a low-priority sector found her. She was in good physical condition. She was calm. She had, by her account, been sitting in the location where she was found for approximately 3 hours. She did not know where she had been before that. She said the last thing she remembered clearly was stopping to eat lunch on the trail, an event that occurred by the timeline approximately 48 hours before her recovery. The recovery location was 11 miles from where she had eaten lunch, in terrain that the probability model assigned a probability so low that it had not been included in the initial search grid at all. 11 miles, 48 hours, in terrain that the ground team described as genuinely difficult, not technically extreme, but the kind of rough, brushy, trackless terrain that slows experienced adults significantly. She was 63 years old. He said, "I ran the numbers on this case many times, even under the most generous assumptions about her pace and her route-finding ability. She could not have traveled 11 miles in that terrain in 48 hours in the condition she was found in." He said, "And she was found in good condition, not exhausted, not scratched up from forcing through dense brush, not dehydrated or hungry in the way that 48 hours of strenuous travel in rough terrain would produce." He said, "The numbers don't work." He said it with the specific expression of a person who has tried to make the numbers work for 15 years and has accepted that they don't. He said, "I've stopped trying to force a mechanism onto cases like this. I just document the deviation from expected outcome and note the terrain characteristics and keep looking." He said, "Because looking is the only thing I know how to do with it. The question of what is happening to people in the exceptional cases, not in the physically straightforward sense of where their bodies moved through space, but in the experiential sense of what they encountered during the time they cannot account for, is one that the analyst has approached carefully." He is not a psychologist. He is not a researcher of experiencer testimony. His expertise is in the mathematics of search, and he is disciplined about staying within that expertise. But he has over 15 years of examining exceptional cases, spoken with enough of the survivors, carefully, in the context of understanding what had happened to them and what their experience might tell him about the mechanism he was looking for, to have formed a general impression. He said, "There's a consistency in what they describe that I didn't expect." He said, "I've spoken with 16 survivors of what I'd classify as the most extreme exceptional cases, the ones where the deviation from expected outcome is so large that no conventional explanation approaches adequacy." He said, "Every one of them describes a period of missing time. Every one of them describes disorientation that is qualitatively different from the disorientation of being lost. It's not spatial confusion, not the panic of not knowing which way to go. It's more fundamental. It's a loss of context for where and when they are." He said, "And a majority of them, not all, but a majority, describe a quality of the environment during the period they can partially remember that they have difficulty putting into words, a quality of stillness, of unfamiliarity with familiar terrain, the sense of being in the same landscape, but in a version of it that is somehow different from the version they entered." He said, "I'm aware of how that sounds. I'm reporting it because it's consistent, not because I have a framework for it." He said, "The consistency itself is data." He said, "Consistent testimony from unconnected survivors about a consistent experience is the kind of thing that, in any other context, would be taken seriously as evidence of a real phenomenon." He said, "In this context, I'm not sure what it's evidence of." He said, "But I'm not able to dismiss it either." The overlap between his exceptional case geography and the other patterns examined in this series is something he became aware of only after the researcher brought it to his attention. He had not been following the broader pattern research. He was aware of Parledis's work in general terms. The missing 411 documentation is known within SAR communities, but he had not examined the geographical distribution of the cluster zones in detail. When the researcher laid out the overlap, the dog refusal map, the weather anomaly locations, the cluster zones from the missing 411 research, and his own exceptional case geography, he was quiet for a long time. Then he said, "That's the same area," not, "That's similar," not, "There's some overlap." "That's the same area." He said, "I've been building my exceptional case map from recovery data. Someone else built a map from dog behavior. Someone else built a map from weather anomalies. Someone else built a map from general disappearance clustering." He said, "And they're the same map." He said, "That is not a coincidence." He said, 4 independent datasets, built by 4 people who are not in communication with each other, using 4 different methodological approaches, producing the same geographic distribution." He said, "In any scientific context, that level of convergence across independent datasets is treated as evidence of a real underlying phenomenon." He said, "I don't know what the phenomenon is, but I'm confident now that there's something real to explain." He said, "And I'm going to keep looking." The case database that the analyst has assembled across 15 years contains one category of recovery that he finds particularly difficult to account for mathematically, not the cases where the subject is found in a searched area. Those can sometimes be explained by searcher coverage gaps, by subjects moving after an area was cleared, by the specific limitations of human visual search in dense terrain. Not even the extreme cases where the recovery location is beyond what the probability model assigns non-zero probability. The cases that resist his frameworks most completely are the ones where the recovery location is in an area that was searched more than once. Not searched and missed. Every SAR coordinator knows that searches can miss people who are present. Ground team coverage is never complete in rough terrain. Visual search has inherent limitations. A person sheltering in dense brush or under a rock overhang can be missed by a passing team. The cases he finds most anomalous are the ones where the evidence suggests the subject was not in the recovery location when that area was searched, and then was there when it was searched again. He described this with the care of someone who understood how the words would sound. He said, "I'm not saying people are being moved. I'm not saying anything about mechanism. I'm saying that in a specific subset of cases, the documentation supports the conclusion that the subject was not in the recovery location at a time when the recovery location was searched and was in the recovery location at a later time." He said, if a subject moves from an area before it's searched and then returns to it, that produces this result. That's the most conservative explanation. He said, but in several cases, the evidence for subject movement, the physical evidence of travel, the condition of the subject, the testimony of the subject, is inconsistent with the subject having traveled to and from the recovery location under their own power. He said, so either they moved and left no evidence of moving, or someone or something moved them. He said, or, and this is the option I find most consistent with the totality of the data, they were somewhere else entirely during the interval, and then they were back. He said, I don't have a framework for that, but it fits the data better than the alternatives. He said, somewhere else. He said, and then back. And the map of where these somewhere else and back cases cluster overlaps with the map of everything else. The map is not complete. The 4 datasets that produce it, disappearance clustering, dog refusal locations, weather anomaly documentation, exceptional recovery geography, are each imperfect in their own ways. They are all based on incomplete documentation, on the informal notes and personal logs that exist alongside and sometimes in place of official records. They are not systematically collected. They have gaps and biases that a formal research program would be designed to address. But they converge. Across their individual imperfections, they point at the same terrain, the same elevation bands, the same geological configurations, the same relationship between rock and water and drainage that appears throughout the documentation of cases in this series. The analyst said, in the final minutes of his conversation with the researcher, "You know what I keep coming back to?" The researcher asked, "What?" He said, "The dogs. The fact that the dog refusal map overlaps with my exceptional recovery map." He said, "Because the dogs aren't using probability models. They're not using weather records or case documentation or statistical analysis. They're responding directly to something in the terrain, something they can perceive that I can't model." He said, and they're responding to it in the same places where the models break down. He said, which means whatever the models are failing to account for, whatever the mechanism that's producing the impossible recovery locations, is something that the dogs can detect. He said, the dogs know where it is. They've been telling us where it is for years. He said, we just don't know yet what they're detecting. He said, but that feels like the right question to me. Not why are people going missing in these places? Not why are they found where they couldn't have gotten? But what are the dogs responding to? And what does whatever they're responding to do to people who walk into it? He said, if we can answer those two questions, we might be able to answer all the others. The episode that follows in this series moves from the mathematics of recovery to the geology of location. The terrain features that appear in the maps, the boulder fields, the geological transition zones, the water convergence points, have a physical basis. The specific combination of rock types, fault proximity, underground hydrology, and electromagnetic complexity that the geologist identified in the dog refusal terrain is not metaphorical. It is measurable. What it does, what physical processes it produces, what effects those processes have on the environment immediately above it, what a person walking through it might experience that they would not experience in adjacent terrain without those characteristics, is what the next episode examines, not to provide a mechanism for the disappearances, not yet, but to describe the specific physical environment of the terrain features that the four independent maps have converged on, to begin the work of understanding. What is there in the specific configurations of granite and water and geological boundary that the dogs detect, that the weather sometimes precedes, that the probability models fail to account for, and that the people who enter sometimes do not leave the same way they came in?